All right, number 34. In a circle with center O, central angle AOB has a measure of 5 pi over 4 radians. The area of the sector formed by the central angle AOB is what fraction of the area of the circle? Okay, so what we have here is we have like a circle here. And then this circle is, we have a certain angle, right? It's forming a sector. And this angle measure is 5 pi over 4 radians. So this angle is given in radians, right? So we can measure an angle in degrees or in radians. So radians is another way to measure angle. And what happens, the sector here, right, is this part of the circle. So it's like a partial area pretty much. Okay, so the area of the sector, and the area should be should be proportional as the area of the circle, right? And its ratio is going to be the same as the ratio of the angle, the central angle compared to the total angle measure of the circle. Okay, so what we can do is we can do this. Say if the angle there for the sector is 5 pi over 4, right? So this picture is not perfect. Might not be drawing it to scale, but let's just say this is the angle that's 5 pi over 4 there. Okay, so this angle is 5 pi over 4. What happens is this is a radian measure. And for the whole circle, we want to remember the whole circle always have 2 pi radians, right? 2 pi radians. So that's for the whole circle. And then what we have here is if the fraction of the angle is 5 pi over 4, right? The angle is 5 pi over 4 and the whole circle is 2 pi, then to figure out the fraction of the sector area compared to the whole area of the circle, we can just do the central angle 5 pi over 4, and we can divide it by the whole angle measure of the circle, which is 2 pi. Right, and that should give us a fraction here. So we're going to do that. 5 pi over 4 divided by 2 pi, we can rewrite it as times 1 over 2 pi. Okay, dividing by 2 pi is same as multiplying by the reciprocal, which is 1 over 2 pi. So you're going to multiply this up. We get the top times the top is 5 pi times 1 is 5 pi. And then on the bottom, 4 times 2 pi, that's 8 pi. And see how the pi will cancel, right? So we get, in the end, 5 over 8. Okay, and that will actually be the answer here. So the fraction of the sector compared to the whole area should be 5 over 8. Okay, so another way of thinking this is we can actually convert it to degrees. Okay, so degrees are usually we're more familiar with, and we're more used to degree. So what we can do is, if we do it like that, we convert to degree, we can do 5 pi over 4. To convert from radian to degree, we always multiply by 180 over pi. Okay, 180 over pi. So what happens, the whole circle is, we said, 2 pi radians, and the whole circle is 360 degrees. So if we do 1 pi radian, it should correspond to 180 degree. Okay, so we do 180 over pi. This as the converting ratio. Okay, so if you multiply this out, the pi cancel, we get 180 times 5, and then divided by 4. Okay, which is 225. Okay, so this equal 225 degrees. So we know the angle measure is actually 225 degrees. So my drawing is way off. Okay, it's actually a much bigger sector. Okay, so 225 here. Then it's gonna be, then we know for the whole circle is actually 360 degree, right? Once we convert to degree, we can just divide by 360, and that should give us the fraction. All right, so 225 divided by 360, we can reduce the fraction. If we divide by 5 on the top and the bottom, we get 45 over 72, right? And we can reduce it again, divide by 9 on the top and the bottom, we get 5 over 8. Okay, so it's the same answer that we get in the end. All right, So that should be it. Yeah, so we don't actually have to know the actual area of the circle or the area of the whole sector. We can just use the angle measure, right, divided by the measure of the whole circle, and then that should give us the fraction, which is 5/8.